Okay, it seems we are live, and the plan for today is to not implement any new features, but just focus on what we already have and make the code more comprehensible and understandable, so other people can take a look at it and do the similar stuff and implement the test runner in a similar way, or they can contribute or maintain this code that we are working on. So today's streams can be boring because I will be adding 0 features and just reworking existing code. I won't try to make it boring, but very likely it will be. Maybe we will add some features if we finish our refactoring early. But the overall plan is to just improve the code quality of the test runner inside our testing library. I'm under Tropin. I work on operating systems and programming languages, testing new angles for the camera, and do a lot of free and open source software along the way, including this small but beautiful testing library. Okay, so far we have a lot of functionality. We kinda finished with our API for macros, and you can see they are impressively simple, even deceptively simple. But the main logic happens not inside those macros, but inside our test runner. The change from the previous stream, I guess, important change, that we reattached the metadata from our test suite sunk to load test suite sunk, because test runner don't have access to test suite sunk, and it have access only to load test suite sunk, which is stored inside our test suite sunks. And that's okay. We attached the metadata to load test suite sunk, and we attached load test suite sunk to test suite metadata. So people who exploring this library and introspecting the functions will be able to find this correspondence or chain of transformations, so they can follow the metadata of test suite to find load test suite sunk and to find the metadata for it. I just understood that maybe we would like sometimes to skip the loading of the test suite and not call load test suite sunk at all sometimes. And it's actually possible because we already have a link from test suite to load test suite. And that means that we can explore the metadata of test suite itself and check if load test suite metadata contains some special values that we need to respect. Okay, so it seems like very flexible and we don't lose much functionality, or do we? Yes, that's good. That seems quite nice. All the problems with this additional nestness comes from the fact that we want to have two interfaces to run tests. First one is explicit when we list of test suites that we want to load and run, and the second one when we actually just execute a test suite and it automatically calls load test suite sunk and if it's a top level test suite, it will also run all the tests loaded. Okay, I would like to stop talking so much and to focus on refactoring. And if you get any questions, come and ask them. Even if you do it after the stream while recording, while watching recording, or maybe while recording, it will be also cool. I don't know if thinking out loud helps or distracts me. It definitely makes it harder because I tire much faster. But I don't know if it helps. Also, another small change that we did, we factored out this function, make try loads with, and instead of deep nested let here, we now just have a simple call to this helper, and the logic of load the suite became much clearer. But let's start from the basics. The basic will be our run assert macro. When it called when assert is executed, and assert passes a few arguments. It passes a thunk to execute, it passes arguments thunk, which allows us to evaluate arguments, but it's better not to call it unless it's really needed, because it will be called when we actually run or assert thunk. I mean, the arguments will be evaluated, and if you have some side effectful argument, which is a very bad idea usually, it will produce two side effects because it will be evaluated twice. Okay, and quoted forms that we can use to do our reporting and all that stuff. And that thing basically checks if we are in the process of loading, and right now we are inside test suite but not inside test, it will throw an exception. And it's very logical, because the test suite just defines the hierarchy, and the actual running and rerunning of tests happens inside test body. Sounds very reasonable. And default run assert, let's see, with exception handler, when we have test, we put into test events an error, and we ask test reporter to report an error. Quoted form. We actually could put arguments thunk as well here. Do we? Or maybe not, if you already got an exception. Maybe it's better not to touch arguments thunk. By the way, to do. Ensure arguments sunk exception I will just throwing to do all around the code, and maybe later somebody will clean it up, and I hope that somebody won't be me, but probably it will. When I feel that somebody watches me, it put too much pressure. Write down evaluation time, report start before evaluating the form. So far looks good. So far looks good. The only improvement that we can do is to make safe arguments sunk. Define safeify arguments, safeify sunk. What do we want to actually do it? Let's just try how it works at the moment. Oh, it fails. Expected syntax. Of course. We have our macro and we want to compare it high throw hey. Produces error. it's called only the assertion failed. Let's do define a flaky throw. Let switch throw false. If throw begin. How to toggle it? Set throw. Throw. Okay. Oh. What did define flaky throw? So this function return whole throws exception. Let's set throw to false. It says return a value throws an exception. Let's introduce it here. Exception, exception, exception. And not clear. Okay. Let's try it one more time. By the way, it says sharp F. Why so? Produced error. Assert quoted form. Let's make sure that our state of application is clear. Let's valid. Is equal expected. Assert error. Okay. we forgot this one. Good. Let's fix our reporters actually. First of all, I would like to do like this. So first we write an expression, and after that we write something that we expected. What I trying to achieve, I try to print the expression first. We can even pre-print it. Instead of S, we will do Y. Oops, it was small mistake. Don't need \n here. First we print the expression, after that we see if it fails or not. It's actually not very useful to return just result, because it's always will be false in 90% of the cases. Okay, let's see how it looks. Produced error. Oh, this one is interesting. How the heck it produced an error? Boop, boop, boop. Default run assert this function. We have result sunk, form sunk. Okay, I got it. I got it. Length of quoted form. And if it a list a quoted form. Okay. Okay, I guess good enough. Let's just commit it. Suitable. Fix. Actual. Refactor in case of how to formulate it. Fix actual in verbose reporter. let's do a small break, and I will type a bit. It's probably looks okay on the video, but it feels so slow and unresponsive when you actually type it during the stream because of CPU load, I guess. Like you are inside the jelly and it's hard to type, and the cursor don't move. Like it moves much slower than usual. Okay, let's say that our default run assert is good enough for now. It returns result. It reports what it has to report. What if inside test reporter we introduce exception handling? Sounds like a good idea. Actually, we didn't finish with this flaky throw. Compound exception. Why it happens? It's unclear. Flaky throw. Let's do exception with message. Okay, with message. Flaky exception. Okay, we get flaky exception. Okay, it's fine. Now we're hitting this problem that arguments evaluated twice and it always produces an error. However, it's not the error that we actually got. Okay, now let's implement define safeify some with exception handler, length exception. Let's say exception. Otherwise, lambda value sunk. this. Save arguments sunk. Safeify like this. And now save argument sunk. If you have value something, then do this. If we have exception, say arguments sunk failed. Exception, hopefully exception. Produced error. Assertion failure. Message. Wrong type to apply. Why the heck you try to apply it? Okay, safeify. My bad. That's good. Oops. Message flag exception. This one is good because if I call flag is row now, you see now it says produced error, flag exception. Now it says evaluation of argument sunk failed with Remove PK. And one more time. Evaluation of argument song failed. That's right, because flaky throw returned ho, and after that it returned an exception when we tried to print arguments. And now it produced an error. The error is printed, and next time it will return ho. If I evaluate it right now, it will return ho. And after that it will always fail like this. That's good. Oh, I missed a lot of messages. Sorry, what language is this? Man, it looks like a closure, but it has SCM extensions, so it's Guile scheme. That's true, that's right. So it's pretty similar, but stupidly faster than Clojure and no JVM integration. Much smaller ecosphere. I see. Is it compiled or JITed? I love Clojure syntax, but hate the fact it legit sucks in performance. Both, I think. It is compiled to C, I think. Oh, really? Can I link C libraries to it? The answer is yes, you can like call C libraries from it, and there is FFI interface. However, it's not exactly compiled to C. It's compiled to the bytecode, which get executed by virtual machine, by Guile's own virtual machine. Myself, I made an app using Clojure plus Postgres and had monthly server cost around 150, around 1 GB RAM baseline requirement. I don't know, like JVM is not like very thin, but it's not huge, and also 1 GB RAM doesn't cost 150. You're probably buying very expensive server. However, maybe it uses much more, so it makes sense. I don't know. This time around I'm making an app using Guile plus SQLite and not breaking 100 megabyte yet. Oh, you have some like dynamic cost of the server depending on how much RAM it uses. I do miss Clojure maps, but otherwise I'm totally happy with Guile. I miss a lot from Clojure actually. I miss a lot. One of them is immutable data structures. There are some implementations in Guile as well, but they are not integrated in the language. And the worst part, not the worst part, but one of the bad parts, that they're not only integrated, but it's quite hard to produce a good integration for it, because you need reader literals, and setting up reading literals in scheme is non-trivial. It's a side effectful operation, and it's thread local. So if you run another thread, and in first thread you set the reader macro, the second thread will know nothing about it. So you need to start it as early as possible. And of course, if it's not a part of default distribution of the language, you will have a lot of problems with it. And without literals, like, it's not handy to operate with those immutable data structures. And moreover, the basic operations are not polymorphic. For example, you have vector map for vectors and a map for lists, and hash table map or something like this for one kind of hash table, and immutable hash table map for another kind of hash table, and so on. And it's sad, because in Clojure it's much more expressive. You can use the same function for all the data structures which is iteratable. Like, you can use map with hash maps, with sets, with vectors, with lists, and so on. First of all, about resources for the language. There's like scheme books. You just Google scheme books and you get a lot of stuff here. SIGP, how to design programs, essentials of programming languages. Actually, I have it, I guess, but I didn't read it yet. The little schemer, the reason schemer, they're a bit old, at least the first one, and not very pretty, but still viable. The scheme programming language is a default reference book which explains all the basic parts of the scheme. It's not that conceptual like those books, or not that educational as this one. It's just a reference of the all functionality you can find in scheme language. Introduction to scheme, blah blah blah. So to get the basics of the language, if you already have experience with other languages, this book is quite good. You just go through chapters and see what functionality presented in default scheme implementation. And after that, you take the documentation of your particular scheme implementation. For example, you can use Guile info manual. Yep, it has a web version, and I also use it directly from Emacs. I have like define. I can get directly to the define. I have match, and I can see the patterns that I can use, and so on. Probably another reason why my code looks like a Clojure, because I have a quite extensive Clojure background and use a lot of approaches and stylistic things from Clojure, so it looks similar. Okay, anyway, it's jumped to info manual actually. Control H, capital S. Nothing like exceptional, like basic functionality of info manuals. It will work for other languages too if they have info manuals. But yeah, probably it's not easy to explore, but I was like curious about what Control H commands we have, and found out this one, and yeah, quite useful. And also you can jump to definition using Arei Guile ID and see how it implemented in the code. The Guile implementation of some parts of the scheme is not very clean and readable and understandable, but still viable. Okay, let's get back to our work. I would like to make a test out of it. But I don't want to do so. I would like to, but don't want. Unless I integrated test runner into my IDE, it's not very comfortable to run tests and rerun them. Actually, recently a new addition to Emacs Arei and Guile IRS landed, and let's see how it works. First of all, let's fetch a fresh version of Arei. Okay, let's see if we have, oops. Okay, it finished. Now let's see. Okay, we have this important change. The second stuff, Emacs Arei. Let's fetch updates for it. As you can see, I stopped my development of Arei when I faced the issues with Surface 64 and the integration of it into what? Into Arei and into Arei as well. Tropin downloaded this one. Looks good, and now let's open my configuration and let's rebuild my whole operating system. Oh, only home environment. Make configure. I'm curious, guys, where from? Like, it's 8 AM in the morning, and it's probably the middle of the night in Europe. And it's evening in States, and it's like 10 AM in Japan, I guess. 9 PM here, Eastern US. Cool. 9 PM is not that late. I usually actually go to sleep around this time, but for average person, I guess it's not late. If it's Eastern US time, so the Western US time should be even earlier. So I have a world clock. World clock. Tokyo 10 AM. That's right. Los Angeles It's just 6 o'clock and New York 9 p.m. Oh, we actually live in a different days. I'm already in Wednesday. You're still on Tuesday. Okay. My whole home environment rebuilt. Now I have a fresh Emacs. Partially fresh. And let's see what new we have. I will start res or beta I will start res here. Now we'll connect to it and let's try to throw an exception of like exception, for example, right? Oh, and you can see it printed the message and added a backtrace, and inside this backtrace you have a clickable things with exception handler, a bit unrelated, and start stack, also a bit unrelated. It's already closer. And now we actually jumped like the latest thing on the stack is actually our function, and we directly jump into it. So I evaluate. Oh, I'm missing a parenthesis. Fuck. Wrong type to apply F. Okay, that's good. This exception is handled, but this one is not, and we can jump to the place where it gets called. Nice. You can see we're jumping through the stack. It is the work of Noe Lopez, who is doing an internship in Arei at the moment, and he made it possible to get a backtrace directly when the exception is thrown. Probably we'll put the backtrace into a separate window later, where it's a bit more comfortable and will allow us to do some additional magic, but we will see. Now it's good enough in here. The only problem is that we don't have procedure names. We don't have procedure names because we have too much optimization enabled on Guile, but whatever. At least we can like click on it. It's already very nice. Parent B, KB, lucky throw. you can see the number of arguments increased. And we can jump to it. And we can jump to this one. Nice. Very neat. However, procedure names should be preserved in the stack. Probably I need to tweak the optimization level, or maybe I will just add minus debug here and we'll restart it. Does it have debug now? Yes, it has. And let's connect, and let's, where did the parentheses go? No, it still doesn't provide function names, so probably we need to also specify optimization levels. Sorry, I get distracted from the library work, but it's so much fun to try out new functionality. Compile, read and compile. Warning, optimization, default optimization level. Default optimization level. Make parameter okay, it's from 0 to 9, so if we update in our evaluation and we set optimization level here, to 0. It probably won't help at the moment, and we will need to restart it. But after restart, I hope we will get a lower optimization level. Still no success. Compile. This is the only place. You know what? What if we eval the whole namespace and now? No. I just I was thinking that it's probably because of after compilation, which happened earlier. Let's remove the cache. Let's compile. Let's compile too quick actually. I didn't expect it to compile so quickly. Compile. Is it right? Compile minus help. Yes. Let's run it. I guess we got a bigger exception this time. I mean bigger backtrace. But still not big enough. Let's remove everything again. Return. Boom. Okay, I need to ask my intern how to get more reasonable naming here. Actually, it's a good idea for blog post or for a video to demonstrate this functionality, because it's like really huge. You get an exception and you can just jump directly to the problem. What an improvement. Actually, I'm quite hungry already. It's just 8 o'clock, but I'm already hungry. And we not yet improved our runner much. We improved the reporter but not runner. Okay, let's see what changes do we have at the moment. No changes, okay. Boom. Let's do small stylistic change, because right here right here and let's see if we have it anywhere else. just purely stylistic to make it more uniform. Suitable use chain macro for constructing exceptions. Nothing changed except like the representation. And let's make sure that still works. It still compiles. Why it's so fast? It's like insanely fast. It's very nice. Probably that means that it is the speed of evaluation without compilation. Quite impressive, quite impressive. This is the thing that was bothering me about Clojure. The startup time is ridiculous. It's like a few seconds or few dozens of seconds back in the days. Okay, suitable. I still have questions to the implementation of this one. Because we don't actually schedule tests but create a suite, and we put the test into suite and we run the suite. However, it called run scheduled tests. So maybe we need to make a naming a bit more clear here. But okay, I guess I will try one more time this exciting functionality and we'll get some exception somewhere in the middle How about this one? Will it fail? And we'll come to suitable tests. Suitable tests, and we'll find run tests, and we'll get an exception. We'll click here and we'll see where it was wrong. Very cool. And we'll come up the stack. Run schedule test. Nice. Oh. Run schedule suite. And we even see that we have procedure test, which is not very clean name. But it is what it is. I'm curious if we can change it. But anyway, you can see even the loop arguments. This is so fucking nice. Okay, it's probably outside of our interest because it's some internals. But this one, pure enjoyment, pure joy, or pure enjoyment, whatever it is, it's so cool. Like, you see, I'm jumping to the loop where stuff failed, and we see the iteration of the loop right here. And we see that run scheduled suite get called, and run scheduled test get called, and after that we got to the point where our run test called. It's not clear why run test is not saved here. Why is the name is not saved here? It's very interesting. Let's return our optimization level and let's check it. The stream of cleaning up the library became the stream of trying out new functionality for ID. We commented it out. We take return, restarted our arrays. We came back, connected to arrays, suitable test, while suitable tests, run tests. Oof. A lot of stuff and completely unclear why it failed. compile. Oh, cool. Test runner. Yes, that's right. It happens inside test runner. Run scheduled suite, and run scheduled test. We have procedure test as argument to it. Very clean. And we didn't have an optimization here. And let's return back after compilation, and let's remove debug first. I just want to see the difference. I'm curious why we don't have the rest of the stack frame. Pom suitbl. Suitbl evaluation. Make stack. Okay, makes some sense. I still have a feeling that something is not recorded in our stack. I guess I know why. Because the function got inlined. That's probably why. But setting optimization level doesn't change anything. Is it respected at all? placed it past further, but still not sure if it's respected. I wouldn't surprise if it's not. Okay. Okay, this one is much better. Run schedule test and run test, and inside run test we have parameterization with fluid asterisk. This one is much more precise, and we have loop and loop here. If you just in case you are not familiar with this concept, there is a named let which allows to recursively call the same let but with different parameters, which is basically the same as defining a lambda and calling this lambda. That means that this loop is not actually a loop-like iteration mechanism, usual iteration, but it's a function call. So having them in the stack trace makes a lot of sense. Evaluation, optimization level, return, and come back here, eval, and run. Yep, optimization level definitely helps, and I will keep it. Probably we can include it in the default settings. Cool. The only problem is that run test for some reason is not having a name. How cool it is. We have a function run tests. This part of the stack is not very interesting for us. It's okay if it remains. But I thought that start stack will cut it out. Okay, anyway, we have the whole stack right now. We call run tests, which have two fluid wrappers. And after that, we call test runner with run schedule test, and we get to the point with so nice. It's so nice. It's so huge. I'm so excited about it. Oh, there's like much more comments. Let me read it. Today I learned. Regarding compilation, I occasionally run into an issue where repeatedly compiling will eventually kill the REPL geyser with too many root sets. I don't know if it will happen the way you are doing. First of all, I don't use geyser for quite a long time already, because we implemented a different IDE called Arei. Areas, which consists of two parts. Arei is frontend, Emacs frontend, and Areas, which is a backend. And the thing that you see me editing here, like evaluation file, is actually part of this backend of ID. And a recent introduction is this beautiful stack viewer, backtrace viewer, with ability to jump to a particular problem. About too many roots sounds like something related to garbage collector, because I don't think I can't think of anything which can have the name roots in context of the language. So it's probably related to garbage collector, but I don't know what happens. Probably it's not related to geyser. I'm under the impression this is a Guile bug regardless of which repo, but maybe wrong. Yeah, it's very likely a Guile bug. The only thing that IDE can do is to call something internally to spawn too many objects or something like this. I did end up manually calling GC. I don't know if it's totally resolved. Sounds not very cool to call manually GC. To continue work on your project. I mean, it's not about you. It's about the fact that you have to do it. It should not be required in usual usage of the language. It would be cool to report some kind of minimal reproducer to Guile devil. Even if maintainers won't reply on it, you will be able to share it with someone else, with me for example, and I will try to replicate this problem in my stuff, and maybe even will try to debug it, or maybe not, we'll see. Let's finish up on this beautiful note where we got such a beautiful stack trace and was able to jump around it. Let's do a small recap of what we've done here. We have a lot of unpushed stuff, and the actual stuff we did today. We fixed two problems. First one, forgotten assert quote form for errors. Instead of like a quoted form, we got F, like sharp F for false, when we got an exception. And instead of beautiful message, we get a little less beautiful message. We also fix the problem with a single argument is usage when there is no like items in the quoted form, because the quoted form itself is just symbol or atomic value or something like this. We made a bit prettier our verbose reporter. At least I think it's a bit more useful to pretty print the expression, because sometimes you can get very cumbersome expressions. Let's find some test here and let's fail it. For example, this one is, you can fail it like this, and let's run tests. We get interrupted. Okay, let's fix, let's not throw exception. Run and let's change to base. How much faster it became without after compilation, it's like amazing. And now you can see that the expression is get pretty printed. It's not exactly pretty printed as it was in the file, but still manageable. We can do a dirty magic and to actually extract the code from the file itself using macro, but it's too dirty and I don't think I want to do it in nearest future. However, it's possible. I'm sure it's very possible. The only problem is that it won't work in repo, I guess, because we don't have file. But still. You see what we've done here? We made it pretty printed, the expression pretty printed, and after that we put like tick or X in case of fail, failure, which makes sense. Like expression okay, expression okay, expression okay. Yeah, sounds good to me. Sounds good. Sounds reasonable and relatively readable. Of course, it would be cool to make it, you know, verbatim. I guess this is the right word, like a different font, so it's distinguishable from the message itself. But good enough. Okay, let's get back to our commit history. We fixed a problem with exceptions in the arguments. If exception is flaky in the arguments and arguments called the second time, we get this exception here, and it can lead to very unclear errors. We handle this case very good. We are very nice people and we caring about our future developers who will be using our library. And couple more enhancements. The first enhancement is a stylistic enhancement of raising an exception and adding a chain marker. And another one is using this instead of test runner. Not a huge, but very funny change. And a new line, of course. The most important change done on today's stream is adding a new line. I already read this message. Okay. Today's streams was useful, and hope it was useful for you as well, and you enjoyed it. See you in a bit.